now. All right, very good. Hello, A6 Algebra 2 CP. This is March 31st. It is time for some Algebra 2. Today, what I would like to do with you is I would like to review one of the problems from the document that I posted to be completed for today. Particularly, I'd like to review problem number 3 with you on solving radical equations. It's one of those double radical problems where you have to distribute twice. After that, I'd like to get into some applications and word problems today, which I know makes everybody freak out when I say word problem, but the word problems in this unit are really just working with equations that you've already dealt with in your previous math classes, namely, well, I don't want to give it away. You'll see in a minute. But working with those types of equations and just solving for information that you may not be used to solving for. So, again, we're going to see what that looks like in just a moment after we go over a problem like this. Something else that I want to say is that just a quick reminder to post attendance on Google Classroom. Just go ahead and fill out that attendance form. It's the same form every time. Just mark that you are in fact present. And also make sure that you have your microphones muted and your webcams disabled if they're not already. If you do have a question though, feel free to speak up or type it in the chat. Miss Mao is here monitoring the chat too. So if anybody has any question at any point, do not feel like you're interrupting. Please, please, please chime in, because we're here to help you. All right, so let's get started with one of these problems. Like I said, I really want to go through problem number 3 from the previous homework assignment because I think that's a really great problem that exemplifies all this stuff with these double radical distribution problems. So I have, in problem number 3, the square root of 10 minus 2x is equal to 2 plus the square root of 2x minus 6. Just like that. Right? And the thing that's somewhat unfortunate about this problem is it's impossible for us to isolate both radicals simultaneously. If we have this constant of 2, it's either going to be stuck onto this square root over here, or we could subtract 2 for both sides, but then it's just stuck on that square root over there. Regardless, we have this lingering constant of 2. So we just kind of have to deal with it. And the way that we deal with it is we have to square both sides and eliminate one of the radicals, combine like terms, simplify, set up to eliminate the other radical, and then able to solve it like normal. So let's take a look at what that's going to look like. I'm going to start by squaring both sides. That will help me eliminate the square root on the left side. That gives me now 10 minus 2x is equal to, here we have to do a little distribution, 2 plus the square root of 2x minus 6 times itself. 2 plus the square root of 2x minus 6. Okay? Now I just have to do a little first, outer, inner, last on that right side. That's the distributive property. 2 times 2 is 4. I have 2 times the square root of 2x minus 6. Which is equal to exactly that. It's 2 square roots of 2x minus 6. Think if this were just an x and you did 2 times x, you would write 2x, right? It's the same idea. 2 times the square root of 2x minus 6 means you now have 2 square roots of 2x minus 6. Same thing on the inside here. I now have another 2 square roots of 2x minus 6. And lastly, I have the square root of 2x minus 6 times the square root of 2x minus 6 is in fact 2x minus 6. It's just equal to itself, right? Cool. So hopefully nobody has any questions as to how to distribute with those radicals in there. Now we can go ahead and combine some like terms. So on the left side, I'm going to keep things the same for now. On the right side, notice I have this 4 and I have this negative 6. We're going to combine those together to make negative 2. I also have this 2x, which doesn't really combine with anything else on that right side. I now have 2 square roots of 2x minus 6 and 2 more square roots of 2x minus 6, which altogether makes 4 square roots of 2x minus 6. Did everybody see that, how that works out? One super common mistake that I want to point out, and it's very tempting to do, is a lot of students will combine these two terms together and just do 4 plus 2 and make this 6 square root of 2x minus 6. But you wouldn't do that if we were just dealing with normal variables. Like if I had this written out, 4 plus 2x, I don't think anybody in this class, I certainly hope not, would write 6x, right? Those are completely unlike terms. The same thing happens here. You just have to remember that that 2 is glued to the square root of 2x minus 6. Okay? So just be very mindful of that. I'm now going to isolate this radical by moving the 2 over to this side. I'm going to subtract 2x over to this side. That gives me 12 minus 4x is equal to 4 times the square root of 2x minus 6. Everybody see that? Now, I pointed out something about a problem like this. When you get to this step, it's important to see if you can divide everything by that coefficient evenly. It's in your benefit to do so because it's just going to reduce and make these numbers a lot smaller. So I'm going to, in this case, divide everything by 4. Now, if you notice that you couldn't divide evenly by 4, like say you had a 5 here and a 7 here, then you're kind of out of luck. You just have to square with that 4, and your numbers might get a little large. But in the case where you can divide, it's to your benefit to do so. Something else to point out is say I had like a 6 here, and I had, say, a 10, right? We can't divide 6 or 10 by 4, but you could divide everything by 2. And that helps reduce things a little bit too. So if you notice that that can be done, by all means do it. It helps make your life a lot easier. So I'm now left with 3, that's 12 divided by 4, minus 1x, 4 divided by 4, is equal to 4 divided by 4 goes away, the square root of 2x minus 6. Okay? Now we've just reduced down to a one radical problem that we should be all comfortable with at this point. I can just go ahead and square both sides to get rid of that square root. Again, a little bit of distribution on the left side now. We have 3 minus x times itself is equal to 2x minus 6. Do a little first, outer, inner, last. Again, the distributive property over on that left side, I get 3 times 3 is 9. 3 times the opposite of x is negative 3x. Here we get another one in the middle. And lastly, the opposite of x times the opposite of x is positive x squared is equal to 2x minus 6. Now, as soon as I see, again, that x squared show up, that should be an immediate indication that I need to factor, right? Prime time, need to factor. But before I can factor, I absolutely need to set equal to 0. So we're going to do that by moving this 2x over to this side. It's going to combine with all these. I'm going to add 6 over to this side, combine with that. I get now x squared minus 3 minus 3 minus 2, so minus 8x plus 15 is equal to 0. And we can now factor that down to get x minus 3 times x minus 5 is equal to 0. Again, we need x and x to multiply to x squared. Since we're multiplying to a positive number, we need the same sign for each of these. Since there's a negative 8 in the middle, it makes sense to make both of these negative. And then the combination of factors of 15 that ends up adding to 8 when we combine through distribution is negative 3 and negative 5. That gives us two potential solutions of x is equal to 3 and x is equal to 5. Okay? Again, we say potential solutions because we do have to check for extraneous solutions. We do not want to forget to check for extraneous solutions. So I'm going to do that. Let's first check when x is equal to 3. Is it true that going way back up to the top, to plug all the way back up there, the square root of 10 minus 2 times 3 is equal to 2 plus the square root of 2 times 3 minus 6? Is that true? Let's find out. This is the square root of 4, which is 2. Is that equal to 2 plus the square root of 0? Yeah, that certainly seems like it works out, right? So we get one possible solution of x equals 3. Could be two solutions here. Let's find out. Let's check. When x is equal to 5, do we get that both work out? Is the square root of 10 minus 2 times 5 equal to 2 plus the square root of 2 times 5 minus 6? Is that true? Sorry, I went off the page a little bit. Is that true? I'm not convinced. We get the square root of 0 on the left side is equal to 2 plus the square root of 4. Definitely not, right? Not even close. I don't like that at all. Unfortunately, that means that the solution of x equals 5 is extraneous. But we do still have one answer that works, and that one answer that worked was x is equal to 3. Alrighty? Does anybody have any questions or concerns about that, even in the slightest? Even in the slightest. Questions, comments, concerns? All right, very good. Happy to hear it. Okay, again, if you do, please feel free to just speak up and interrupt, or you can type it in the chat if you don't feel comfortable doing voice chat. All right, now, what I'd really like to get into today is talking about some applications of radical equations. All right, specifically, our applications are going to focus on dealing with equations that you've worked with in your previous math classes, but really just looking at them in a new context. So the equations you've worked with before, you've seen some with square roots in them, but typically you haven't really had to manipulate that square root in order to solve for some given information. What do I mean? Well, take a look at one of the problems that we've dealt with this year, or earlier in the year, our good old fantastic friend. You may already know what I'm going to say. It's the quadratic formula. Now, quadratic formula is x equals negative b plus or minus, it's hard to say it and not sing it, the square root of b squared minus 4ac all over 2a. Okay? Very good. So that formula was used to find the zeros of quadratic equations, right? It's something we've plugged in values for a, value for b, value for c, and just evaluate for x. But what we haven't done, and what we certainly can do now, is what if I said, I'm giving you x, I'm giving you b, and I'm giving you a, can you solve for c? Well, now that we've worked with a lot of radical equations, you should be able to handle something like that. So consider this example right here. Ready? Consider solve for c in the partially completed quadratic formula below. Okay, I'm going to give you that 9 is equal to 5 minus the square root of 5 squared minus 4 times 1 times c all over 2 times 1. Okay? The reason why it's a partially completed quadratic formula is, number one, we don't have the value of c, and number two, the fact that we're just referring to the minus case here. If I did plus or minus, you'd have to split up into two separate problems. That is outside of the context of Algebra 2 CP, so you really just have to worry about this one equation. But regardless, the fact that we have to worry about this one equation means we should be able to focus in and solve for c. The goal is obviously to get c by itself, right? So you just want to get c equals at the end. Right now, it's kind of bunched up with a bunch of stuff. Like it's grouped up with this 4 times 1 and 2 times 1 down here and 5 squared. There's a lot of little arithmetic operations that we can go ahead and simplify. I get 9 is equal to 5 minus the square root of 25 minus 4c. So we're just cleaning up this problem a little bit over 2. Doing some of those calculations you can do in your head, right? Now I see everything here is divided by 2. We definitely want to get rid of that big division by 2 by multiplying by 2 on both sides, giving me 18 is equal to 5 minus the square root of 25 minus 4c, right? Just multiplied everything by 2. Let's isolate the radical like we're used to doing. I'm going to subtract 5 from both sides. That gives me now 13 is equal to the opposite of the square root of 25 minus 4c. Something that I want to point out here, and something that you can certainly do, is you can feel free at this point to square both sides, even though you have this negative in the front here. Negative 1 squared is just going to become positive 1 anyway. You could also, if you prefer, divide both sides by negative 1. That would make this negative 13 on the left side. However, notice that when I square both sides, negative 13 squared is just going to become positive 169. So keep in mind that, yes, you could move this negative sign around, but don't worry about it too much, because when you square both sides, right, you're going to now see that 13 squared is 169. Negative 1 squared is just positive 1 anyway, so it really doesn't even matter. I get 25 minus 4c because the square root and square cancel out. Hopefully everybody's all set on that. Again, if you do have a question, feel free to interrupt or type it in chat. Now it's just Algebra 1 territory, though. We can go ahead and subtract 25 from both sides. I get 144 is equal to negative 4c. Divide both sides by negative 4, and you get that c should equal negative 36. Okay? So that's the value of c that would actually make this quadratic formula work out. Something that I want to point out when we're dealing with applications is, although we've stressed it a lot in our regular solving equations practice, when we're dealing with applications, you do not have to check for extraneous solutions. I'm going to write that right here. We do not have to check, with applications only, with equations for sure, for extraneous solutions. And the reason why is because, number one, these are like proven mathematical formulas that definitely work out. They don't result in any extraneous situations. It's not like random equations that I've given you where maybe it's extraneous, maybe it's not. This is the quadratic formula. It's a proven mathematical thing that there are no extraneous solutions in these particular cases. Same thing if it's tied to a real-world application, for reason number two. If it's tied to a real-world application, it wouldn't make sense for something to be extraneous or for something to not be not come out correctly. Any formula that you're dealing with when you deal with an application is one that is guaranteed to work out because it's this proven mathematical idea. It's a formula that's set in stone. It's not just this, again, this random equation that I'm like, hey, let's see if this works. These formulas definitely work. So that's something you have to keep in mind. Now, certainly, you can check for extraneous solutions if you want to ensure that you did the problem correctly. You could take this negative 36, go ahead and plug it back in, and check your work. This should definitely come out to equal 9. I don't want to discourage you from doing that. I'm just saying it's not necessary in this particular case. Does anyone have a question about that problem? Give you a little bit of time to sink in. A little bit of time to sink in. All right, we're feeling good about that? Fantastic. Let's now try another one. Like I said, we're really going to be revisiting a lot of the formulas you've dealt with in your previous math classes. And for this one, we're not going just back to the beginning of Algebra 2. We're going back to last year in geometry. Oh, yeah. Oh, yeah. Fun times in geometry. I need to find my problem, though, because I don't know where to... Oh, here it is. So consider if I gave you something like this. The distance between 2 points is the square root of 26 units. Okay? I'm going to tell you that the 2 points are negative 2, comma 2 and x, comma 1. And you want to find values for x that satisfy this scenario. Okay. Oh yeah, our good old friend, the distance formula. Now, I know a lot of times when I bring up geometry, it's like bringing up the dark ages for a lot of people. They're like, oh God, I hate geometry. Some people are like, I love geometry, and that's great too. But keep in mind that we're not really focused on the geometric connections here. Like, we're not really going to be doing geometry per se. We're really focusing on the algebra side of things. And namely, we're looking at the distance formula, which you may remember is equal to, it might come back to you now as I write it here, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, where x sub 1 and y sub 1 represent your first coordinate points and or your ordered pair coordinates, and x sub 2 and y sub 2 represent your second. Okay? It actually, in the distance formula, it doesn't matter which one you call x1 and y1 and which one you call x2 and y2. Like, you could call this x1 and y1 if you wanted to, as long as you're consistent and you don't flip-flop. Like, call this x1 and y2. That would be very bad. Okay? But the distance formula is, there's a bug on my paper. There is a little bug. Get out of here. Interrupting the math. All right. Sorry about that. No bugs were harmed in the making of this video. It's still over there. It's still crawling. All right. So, so what I could do, though, or what you've been used to doing in geometry is you've probably been used to taking these coordinates, plugging them in, and just using a calculator to find the distance. However, now I'm giving you the distance, and I'm asking you to solve for one of the coordinates. That now requires a little bit of use of our radical functions ideas that we've talked about. All right? So I can now say that the square root of 26, that's my distance. Don't freak out about the fact that that's a square root. You're going to see that's actually going to be just fine in just a second. Is equal to the square root of x2 minus x1, so I have x, because I don't know what x sub 2 is, minus x1, so minus negative 2, just plugging into my formula, squared, plus y sub 2 is 1, minus y sub 1, which is 2. 1 minus 2 squared. Okay? And now we're just trying to solve for x. Well, one thing that you might notice right at the start of this problem is this big honking radical over all of my stuff. I don't want that radical there. It's ugly. It's in the way of a lot of stuff. We can go ahead right away and just square both sides because that will help get rid of that giant square root on the outside of everything. On the left side, we do the same because the square root and square will cancel out. That's why you really don't have to worry about that. That just becomes regular old 26. That's now equal to, and I'm just going to clean up as I go, x minus negative 2, so x plus 2 squared plus 1 minus 2 is negative 1 squared. Hopefully everybody sees how that works. Okay? Now, this is probably just what your algebra instincts are saying to you at this point, like, what do I do next? I have to expand. I have to distribute and then solve for x. So I'm going to get 26 is equal to, we just have to take that x plus 2 and multiply it by itself. And then negative 1 squared is just positive 1. Distribute the x plus 2's, I get 26 is equal to x squared plus 4x plus 4, right? That's your first outer and last, and then just an additional plus 1 there. You see that value of x squared show up. That's an immediate indication that we have to factor. But before you factor, again, we need to set equal to 0. So I'm going to take this 26. I'm going to move it over to the other side. That gives me 0 is equal to x squared plus 4x. This comes out to be 5. We're now subtracting 26 from both sides. So 5 minus 26 is what? Negative 21, I believe. Now we just go ahead and factor. We need x and x to multiply to x squared. I need one positive and one negative since I'm multiplying to a negative, and the values that work out are positive 7 and negative 3, giving me two solutions here of x is equal to negative 7 or x is equal to positive 3. In fact, both of those x values are possibilities for this point. That just means that you're starting at a particular point. Here's like negative 2 comma 2, and we're just drawing either this way or we would draw this way, right? Regardless, you would still have a distance of the square root of 26. So it is possible that you could get multiple solutions for something like this, and they're both equally valid. Again, no need to check for extraneous solutions. Once again, I don't want to discourage you from checking your work. You certainly can take negative 7, plug it in for x, and evaluate that, and you should get it comes out to equal 26, or the square root of 26, I should say. Okay. Any questions, comments, or concerns about these problems? All right. So a couple things I want to say first, and then I will just do a final problem with you. Number one, if you haven't noticed, I have been uploading all of the recordings online, and I've been posting them on Classroom. Please make sure you check out those videos if you are confused in any way at all. Number two is that I did post another assignment on Classroom for you to complete for the start of next class. That is 5 word problems. I mean, there's a document of 10 word problems, but I'm asking you, please, to complete problems 1 through 5 for next class, which is on Thursday for us. And then please complete problems 6 through 10, which will be, I think, next Monday, if I can count correctly. Okay? If that changes for any reason, then feel free to then just make adjustments accordingly. But know that next class, I expect you to have problems 1 through 5 done. The class after, problems 6 through 10. All right? If you have any questions at all, in any way, please do not hesitate to contact myself or Miss Mao. As far as assessments are concerned, there will not be, well, I should rephrase that. There are going to be assessments. The end of the quarter will be coming up at some point, right? We're still doing distance learning, but we are still in school, so it is important to be prepared for assessments, and that's why I'm asking you to take this practice work seriously, because it should really prepare you for that. I don't really know what assessments will look like at this time, but I will certainly get that information to you once I have that information. As far as summative assessments go, one thing that I do want to say is that after after Monday's class, because next class is going to be a little more word problems, so after Monday's class, I am going to assign to you a progress assessment that will be due at the start of Wednesday's class. What does that progress assessment look like? It's going to be a document, not unlike the homework documents you've seen, containing a couple problems. I'm going to ask you to solve those problems and take a picture of your work, submit it on Google Classroom just like you would submit any normal assignment, and that will count for a progress assessment. Again, I don't know what summative assessments will look like at this time. I'll be sure to let you know as soon as I know. But do keep in mind that we will have a progress assessment that's going to be after Monday's class, and so it will be due at the start of Wednesday's class. Again, if dates happen to change for whatever reason, then so be it. But that's the plan right now. I'll make sure to remind you of that as we get a little closer so it doesn't like blindside you or anything like that. Okay? Great question. Maddie asked, what's everything on the PA? It's going to be a couple equations and a couple word problems. Probably, I'm thinking, as far as the equations go, one of the intermediate level problems, maybe one of these advanced level problems where you have to distribute twice, and then probably 2 word problems. I think that would be fair. That's 4 problems, right? Maybe a 5th equation, maybe a 3rd equation if I think that, but we'll see. It's going to be no more than 5 problems. Let's put it that way. No more than 5 problems. Okay. The PA will just be a Google Doc that you'll have to complete. You can go ahead and take a picture of your work and send it back. You'll have to submit it on Classroom, just like you'd submit assignments for other classes. Okay. Again, I'll have more detailed instructions as the time gets closer. All right. So we have about 2 minutes to go. Thank you for the questions, by the way. That was Maddie and Hannah. We have about 2 minutes to go. What I did for my last class, my A1 class yesterday, is they asked if I could go over problem number 2 on the homework assignment, which was another double distribution problem. I want to offer that same opportunity to you. I know we're really close to the end of class, so if you have to go, then you can go. That's fine. The recording is up on Google Classroom and on YouTube, so please feel free to tune in after the fact. But if you want to stay, I think it is always a great idea to see more practice if you can get the opportunity for more practice. So I'd like to show you that other double distribution problem from the homework if you have time. Again, if you need to go, you can go. That's fine. I totally understand. But I'm just going to do it anyway. So that other double distribution problem, this was problem number 2, looked like this. We had -2 plus the square root of 5x plus 1 is equal to the square root of 3x minus 5. All right. Again, it's another just double distribution problem because you know that it's not going to be possible to isolate both radicals at the same time. This -2 is stuck onto that one on the left. So I'm going to square both sides. I'll go through it a little faster than I've done in the past. Here I have to multiply that by itself because that's what it means to square something. We got 5x plus 1 times -2 plus the square root of 5x plus 1 is equal to square root and square cancel out 3x minus 5. Little first, outer, inner, last on that side. We're going to get +4. -2 times that is exactly that. -2 square root of 5x plus 1. Another -2 square root of 5x plus 1. And then the square root of 5x plus 1 times the square root of 5x plus 1 is just 5x plus 1. It's equal to 3x minus 5. Combining some like terms on that left side, we have a 4, we have a 1. That's going to combine to be 5. We have another 5x, so plus 5x. And then we have -2 of these and -2 more of those makes -4 square roots of 5x plus 1. And that's going to be equal to 3x minus 5. Okay. Now we can go ahead and isolate this radical. We can do that by moving these terms over here. And I'll move this term over here to the right side. I get this -4 times the square root of 5x plus 1 is equal to, let's see, 3x minus 5x, so -2x and minus 10. Now, this is somewhat to the point that I brought up earlier. Even though it's not possible to divide these things evenly by 4, we can certainly divide them by 2. Because it's almost like taking out a GCF. Dividing everything by 2 will make my life a lot easier. That's going to leave me with -2 times the square root of 5x plus 1 is equal to -2 divided by 2, -1x minus 5. 10 divided by 2. Okay. See how that just reduces the numbers, and it's going to make it a lot easier when we go to square. You don't have to do that. It's not necessary, but it's, again, just sort of a quality of life thing. It's going to just make our problem solving process a lot simpler. We can now go ahead and square both sides. -2 squared is +4. The square root of 5x plus 1 squared is 5x plus 1. I now have over here, we'll have to do a little first, outer, inner, last. Oh, whoops, -x minus 5. There we go. Okay. Let's see. On the left side, a little bit of distribution. 4 times 5 is 20. Plus 4 is equal to Distribute here, negative x times negative x is positive x squared. Negative x times negative 5 plus 5x. We'll get another one in the middle, so plus 10x overall, and then plus 25. Set up to factor because we see that x squared. We're going to move the 4 over here. We're going to move the 20x over here. I get 0 is equal to x squared. Let's see, 10x minus 20x, so minus 10x. And then 25 minus 4 plus 21. We set up to factor now. We get x and x because that's what's going to multiply to give us x squared. 2 minus signs are needed because we need 2 of the same sign to multiply to a positive, and I see that negative goal in the middle. I need negative 7, negative 3. That gives us 2 potential solutions of x equals 7 and x equals 3. And just for the sake of time, because I know we're a little bit over, if you do go ahead and check for extraneous solutions, you would find that both of these work out just fine. So this problem has 2 solutions, one of x equals 7 and one of x equals 3. Again, I apologize for going a little bit over our allotted time, but I wanted to make sure I gave you that opportunity to see another problem done out like that. All right. Like I said, it will be part of the recording, so make sure you check that out. Again, remember to fill out that attendance form, but other than that, I don't want to take up any more of your time. Thank you so much for your attention and focus today, and if you have any questions, feel free to ask. But I will see you on Thursday. Will be our next class, April 2nd. See you then. Have a great rest of your day.
Mr. Giorgio, I just had a quick question.
Oh, what's up?
So when you're distributing at the beginning when you did like you multiplied the radicals with each other, yeah.
Sure.
I guess I'm kind of confused on how you got positive, like without the radical 5x plus 1.
Right here, this last one?
Where would that come from?
Good question. So what I did here is I did negative 2 times negative 2 to get 4. Negative 2 times this square root gave me exactly that. Inner multiplication was the square root of 5x plus 1 times this. And then the square root of 5x plus 1 times the square root of 5x plus 1 is just 5x plus 1.
Okay, that makes sense.
That's a great question, Paige. I'm glad you asked.
Have a good day.
Hey, you too. Have a great rest of your day, everyone.